Okay, we'll start. So for today, we're just gonna learn about magnets and how you can make a magnet, electromagnet, and an electromotor. Can you all tell me anything you know about magnets?
Do you attract with other magnets?
Yes, that's one. Is there any other ones?
Like when they're on the same side, kind of. Like if they're like a big magnet and they're like on the same side, then they'll attract.
I think you're saying like unlike poles repel.
Yeah.
Okay, unlike poles attract. Yeah. If you have anything else, you can interrupt me. I'm going to share my screen. Okay, so magnets have two poles, a north and a south. Unlike poles attract, so opposites attract. South poles are attracted to north poles, and north poles are attracted to south poles. And the same poles repel. So if you have two magnets and they're both on the same sides, they're gonna repel. And if they're both north, they're also gonna repel. It turns out that some metals can turn into magnets, like iron, if you apply a little electricity through them. That's where electromagnets come in. All electromagnets is basically if you have a loop of wire, for example, you have this loop of wire, this straight wire, copper wire, and current is flowing through it. Like when you connect a battery, current is flowing through it. There's a magnetic field that's created. Could you give examples of what objects or like create magnetic fields? This is an example of a magnetic field. Can you think of any other examples? There's like one big example that has a magnetic field. So I'll just give you one. The big example is Earth. Earth has a big magnetic field. It has a north and a south. It has a geological north and a south. So yeah, it's just the south is at the bottom and the north is at the top. But there is a real magnetic field that's like 23 degrees tilted on the axis, like of how Earth rotates. And that's also another type of magnetic field. When current flows through a wire, the current creates a magnetic field around the wire, but the magnetic field is very weak. So if you like have a small magnet near it, it wouldn't do anything. Like it wouldn't get attracted or it wouldn't get repelled because it's very weak. So to create a strong field, you can wrap wire, like a loop of copper wire around a cylindrical object, because then the coil overlaps and it has a piece of iron in the center of the loops. So this is like a loop. I'll show you in a camera, but this is a way to create a stronger magnetic field. So can anyone tell me, like from last class, do you all tell me the difference between voltage, current, resistance, and power? Okay, so voltage is the push or pressure of electrons. Difference, yeah. Current is the rate at which the charge is flowing, yeah. Resistance is the material's density to resist the flow of charge. Yeah, that's close, yeah. Or current, yes. Okay, and power is just the brightness of the battery. So in simple terms, voltage is just the pressure or push of electrons. Current is just the flow of electrons. Resistance is just the opposition or the slow movement of electrons. So the electrons won't easily flow if there's more resistance. And power is just the energy output, like for example, the brightness of a light bulb when you connect it to a battery. Okay, so I'll make an electromagnet now. I'll change my camera so you can see my table. So I'll come back like in 2-3 minutes. Okay, so can you all see my screen with the white paper?
Yes.
Okay. So this is a copper coil. This is rusted with like oxygen, so it's like dirty. But I'm gonna make a new copper coil, and then you can follow me with me if you have some copper coil, but don't connect it to the battery, because when you connect very thick piece of wire to a battery, it will easily heat up and it will burn you. So it's better to not do it by yourself and have your parents do it too. So if you actually really want to do this like the proper way, like with the actual real materials to get better results, this is what I bought. It's 18 gauge wire, and it's the size of the wire. So it's 18 gauge. So it's just the size of the wire. Yeah, so if you get it, so for example, this is 18 gauge wire, so it's like thick enough for you to bend it. But if you like buy 22 gauge wire, you might think it's greater, like the thickness of the wire is greater, but it's not. It's very funny, but the greater the like the gauge number, the smaller the wire thickness is. So if you buy something like that, like that's 32 gauge, that means it's very thin. But if you buy something like that's 15 gauge, it's very thick. So 18 would be best for this electromagnet, because it's easy to bend and it's not too thin. If the wire's too thin, there's not a strong current. Like if you have a very thin wire, I'll show you. If you have a very thin wire, the electrons, there's not going to be enough or strong enough electrons to fit in the tiny skinny wire. For example, we'll use 28 gauge wire, and it's very skinny. Like you can't even see it through the camera. It's red, but you can't see it compared to this. It's very skinny, but the red one is 28 gauge and this one's only 18 gauge. So for the electromagnet, you should use like a thicker wire, because then the electrons will easily move and then it can create an electromagnet easily. So first, just get a small pencil. This is round, so you want the loop to be round and like big enough for the nail to go through it. So this is my nail. I already made one, so this is how it just goes through. So I'll make one for you now. You can make it at home too, but just do it with your parents, because when you connect it to the battery, it gets very hot. So you should wear gloves too. So first, you want to have like 2 inches off the pencil and then loop it around. So just loop it around. Like if you have a small nail, then it's better to have more loops. But if you have a big nail like this, you can just have like 50 loops. If you have a nail smaller than this, it's going to be hard to pick up other materials. So with this nail, I could pick up 2-3 washers. You could also just pick up paper clips. So I'll start with like the bending. All you have to do is this. You just do this 50 times and then cut it off in the end.
Wait, 50 times?
Yeah, so 50 loops.
Okay.
Yeah, this is 50 loops.
Wow.
So it's if you have a very big nail like this one, then it's 50 loops. If you have a bigger nail, then it's shorter. But if you have a small nail, it's better to have more loops so that you could have the have the same magnetic strength, so you can pick up more stuff. Yeah. So it's hard to do it on camera. Okay, so every time you loop it, you have to make sure they're like all touching each other. Mine's not touching yet, but once you finish, it'll look something like this. This looks a little dark and oxidized, so that's why it's like brown. Is it are any of you like actually doing it right now? I'm just wondering.
No.
Okay. For the materials, I will just repeat them. It's this 18 gauge, American gauge. That's the units for the size of the wire. 18 gauge copper wire, a big nail in a battery, and just tape.
And where can we find these materials? Walmart or Home
yeah.
Depot?
Yeah, you can find it at Home Depot.
Okay.
The nails are easy to find, so, and the battery too. I would like to have the Duracell Type C batteries. They're like, they have more current going through them, so it's more easier to get an output through these batteries. I tried using the normal batteries, but that it didn't work well, so. The wire is very hard to turn. So you could also use like a tape, like you could tape it here, and then you don't have to hold it, because sometimes when you turn, they'll keep like little sideways loops, which is bad. And if you overlap the loops, it's fine, but just loop it equally. So I'm only doing 10 loops just for the purpose of showing you. And then you can get wire cutters or a scissor to cut the extra off. Okay. These are wire strippers, like you use them to cut wire or the insulation. And so you can just cut it off like that. Okay, so this is very long. Okay, so now you can take the pencil out and then put in the nail, so make sure it fits. And then this is so whenever you're doing with the batteries easily get hot, so wear gloves. And it's dangerous with these ones because they actually heat up, and the wire, like the copper wire, actually heats up. So before I connect it to the wire, get sandpaper. Do you know what sandpaper is?
Yeah.
Okay.
I have some in my fridge.
Yeah.
No,
So
no,
you
not
can
my fridge.
Okay, so you can use sandpaper to take off these pieces. So you think that this is copper wire, this is bare copper wire. There's actually a insulation to keep it clean so it doesn't get oxidized. So you have to take that insulation out so that you can connect it to the battery. If you don't take it out, there's like resistance. If you take the insulation out, it's more easier for the electrons to go through the copper wire. So I'm using a knife, but it's better to use sandpaper because it's more like easier to actually take off. But you can't really see the difference. The only thing you can probably see is it's more shiny. So if you oxidized it, you can see that this part I used sandpaper to take this part out, and it's more easier to see, do than a knife. So you should use a sandpaper than a knife. And like I didn't use sandpaper here, and it's more like dark, and here it's more like not dark. So it's more easier to use sandpaper than a knife. I think I have sandpaper. I have sandpaper. Okay. So all you have to do is just strip all sides of the wire that you're connecting it to. So this will go to the negative side of the battery, and this will go to the positive side of the battery.
Question, is there a chance it can start a fire?
Yes. So make sure that these two never connect to each other when they're connected to the battery. These two sides, make sure they're never connected to the battery. And also, if it gets really hot, like wear gloves, but also give it a break. So the first 3 minutes, it won't get that hot. But once it's like there's a lot of current flowing through the wire will actually get hot, and it like burns you a lot. So wear gloves, and don't let the copper coil touch the battery more than 5 minutes, like less than 5 minutes, just to make sure that nothing's going to smell. Like the first time I connected it, the wire actually had a smoking smell. So make sure it's not connected to each other. Never in electronics, never connect the negative and the positive together. That's how you make explosions. So does that answer your question?
Yeah.
Okay. So this is the insulation. I'm taking off the insulation. You can't see it, but it's there. And the reason they have the insulation is because it's more easier for the copper to rust because it gets oxidized, and that's why they have it, so that the copper won't get oxidized. I'm not sure if this one will work because this is only 10 loops, so I'm going to actually do this one too. You can actually see it getting cleared when you actually see, you can get it, you see it getting shiny. So what's the purpose of the electromagnet? It's just going to pick up some washers, and if you don't have washers, you can just use paper clips. See, now you can tell it's very shiny here and it's very dirty here. That's the oxidized part. And then I'll do the same side here. So you can see how shiny it is on this side and how oxidized it is on this side. You don't have to use sandpaper for this whole thing. The current will go through here and it will go inside the wire itself. So the electrons, you only have to use sandpaper on these two sides. Okay. I have a battery and I have gloves. Use the gloves that are more like rubber and hard so that you won't get burns. Also, I have electrical tape. It's okay to use normal tape, but these are more safer and they have more glue to them, so it's more easier to use those. Also, this is just like a physics thing. So whenever the first time you make this and you're connecting it to the battery, and I initialized that this would always connect to the positive side and this would always connect to the negative side. So in like electronics, always make sure, so in electronics or like an LED, the longest side is the positive side usually, and this is the negative side most of the time. But since I already connected this to the positive side, I already connected this point to the positive side. I just made this the positive and this the negative. So this would be the positive and this would connect to the negative. Can you see the plus and the minus?
Yeah.
Okay.
Yes.
So are you
So-
gonna connect them right now?
Yeah, I'm going to connect them. So always make sure that the connection you have, they're always the same. So once I connect these two again and I like disconnect, make sure they always connect the same way. If you connect it like this, it's going to weaken the electromagnetic field. Does that make sense?
Yes.
Okay, so I'm just going to tape the negative side. So you don't have to tape the positive side either. Just tape the negative side instead. This is the positive side, this is the negative side of a battery. Okay. I'm wearing gloves. I did this without gloves and it very burned me. Okay. So I have paper clips. You could also use other materials like paper clips, like iron or anything else. So I'm going to focus. So the whole material inside, like the nail, it doesn't have to be completely inside. It just has to be some part of it, because materials like iron or metal, any metals or materials, they'll actually get they'll equally get distributed, like the electrons will equally be distributed into the material, so you don't have to have the whole nail inside the actual loop. So we're going to test how many washers or paper clips it will pick up. Right now I'm wearing gloves, so you can't really feel the heat, but just make sure that you're not putting it too much heat on the battery and the wire. So there you go. It picks up a paper clip. So it picks up one paper clip, two. It's better to do it with washers because they actually weigh more. So I'll get washers. These are washers. They weigh each 500 grams. So if you can't pick up a washer, just use a paper clip. The washers are more like for heavy things, but in general, you use washers for wood and like screwing stuff in. Oh, so it got hot, so it was better to take it off. Okay. Oh. Okay. So you just have to wait for like a couple of seconds so that the materials get like connected to each other. Yeah. Okay, so now I'm going to do this. Can you all see my screen well enough? Okay, so hello. Okay, so I picked up 10 last time I did it, but it also matters how much you used the battery. So I used this battery a lot, so it's probably not going to pick up 10 again. That's so this picking up the washers is just an electromagnet. This isn't that cool as an electro motor though, because it's more like easier to see. Yeah, so I picked up 3. For like if you ever do this again, make sure you can tell me how many you picked up, just for fun. Yeah, so it's getting hot. We could use electromagnets to pick up other things too. But the main point of us making electromagnet today was just to see how you can mix current and magnets together to create something cool. Do you have any questions about electromagnets? Okay, so now I'll make the electromotor, which is more fun to make. So for the electromotor, you would need for the electromotor. Did anyone say anything? Okay, for the electromotor, you would need something like near 28 og. So og is AWG. I think that's reversed on the camera, but this is how you say it. So it's og, it's American wire gauge. It's just like the measure or the size of the wire. Okay, so this is 28 og or gauge, and all you have to do for this one is very simple. So I'll get an example. So this is the magnet I'm using for, so you need a magnet for the electromotor. It's just north and south. It's better not to have the ones where there's like a hole in the middle because those like interfere with the magnetic fields. So just have like really one rod of magnet like this. Just have a magnet like this. Where was it? Okay, so I did 2 experiments. So this is what we're going to make out of this wire loop. We'll make this. It's just a small loop, like just like what I showed you yesterday with like with the examples. We're just gonna make this spin, and this spinning is the actual motor. Okay, so I have 2. So I'll make one right now, and then I'll just use these because these were better examples than I'll make now. So this one, there's not much of a hazard of fire or anything because this wire is very thin and it will not use that much current from the battery. So for the electromagnet, we used 50 loops of wire. For this one, it does not matter. It just make it thick enough that looks like this. So I cut some wire, and then make sure you have some like 3 inches off the sides of each side, so then you could loop You could loop it onto a pencil or anything. I'm just going to loop it. This time you must overlap it so it actually spins. So I'm going to overlap it. The 28 gauge wire is easier to loop around a pencil than 18 gauge. Does it make sense? Like when I'm saying gauge, it's just the size of the wire.
Yeah.
Okay. Okay, so I made the loop so it looks like what we made in the electromagnet. And now for the important part, you have to take one of the ends and then put it back into the loop so that it's like tight. And so the loops won't get loose. Make sure you do it like 2 times on each side. And you should like straighten out the wire just for making sure it's easier to spin on the paper clips. Okay, so this is the important part. Where's my assignment? Okay, so for one side, make sure you only strip like sandpaper off one side of the wire, and then the other side, make sure you sand and pretty much do the whole side. So this side, I'm going to do the whole side. So all of this wire is going to show up copper. So this is red. So this whole side's just going to be copper, like the color copper. But this side, only half of it's going to be copper, and then the other half it's going to be red. This is the important part. This is how the motor will the loop will actually spin. So you can just put it on a table and then strip off half of this side. So make sure it's not moving. And so when you actually finish, one side will be red and the other side will be copper. Okay, so I'm not sure if you can see it, but it's very thin. So one side's red and then the other side's copper. Can you see that one side's red and then the other side's copper? Okay, so this is the important part. If the loop doesn't turn, I think this would be the most error that you could get. So this side's copper and this side's not copper. So I ran the insulation here, I took off the insulation here, and I didn't here. And for the other side, I'm going to take off the whole side, like everything, so it won't be like this. The reason for doing this is a physics reason. It's because of the magnetic flux, which is something you'll learn in physics. But all it does is it makes it spin. So when I connect the battery to this loop, I have to give it a push, and once I give it a push, it will run and like twist by itself. It'll spin by itself. It's easier to use fine grit paper, sandpaper, and so because if you use a knife to strip off the insulation, you're more likely to cut the wire instead of the insulation. So it's better to use sandpaper. I'm doing all the sides on this side because that's what creates the magnetic flux. Flux is just a way of saying the magnetic field in an area. So this would be the area, and the magnetic field would be created in this area, in the circle loop. Okay, so this whole side of the wire is stripped, like everything, all the sides are stripped. And then only half of it is stripped on this side. Now I'll connect it to the battery. So I have this battery. So I'll use these paper clips that I already bended. So you have this paper clip here. This is how the paper clips look like. So all you have to do is you have to bend it to one of the sides, just like this. So then it looks like that. So you need 2 of those, and then you can get electrical tape or any tape, and then cut 2 get 2 pieces of tape. So I have this battery, and I'm going to use the longer side because my magnet is like very thick and it's attracted to the battery. So make sure that wherever the circle is, this like circle is higher than whatever your magnet is. So the loop has enough space to spin. So I tape this side. And then I can tape the other side. The hard part about this is putting the wire through without bending it. So you'll have to bend the loop that I just made in order to get into the loop. Also make sure these two circles are equal, like in height. Okay, so now so I think I'll need to strip more wire because it's very big compared to the battery. So I'm going to make more. I'm going to strip more wire. You can also, so this has a small loop. You could also try bigger loops, and those might work easier. Okay, so this whole side is half stripped and this whole side is completely stripped. I'm going to cut off some of the wire because it's too long. Okay, now all you have to do is put it through the actual like circles, like here, into the actual circles. Okay, so this is like crooked, so make sure it's straight. Okay, so it's straight almost. Okay, so now, so it's like spinning like that. Now put like a magnet. Oops. So you have to make sure the magnet's like actually getting turned to one angle where the loop will actually turn. You have to okay, almost did it. So okay, so it's actually spinning. Okay, so there, it's spinning almost. It usually spins. Okay. Okay, there you go. It's spinning. Can you see it all spinning?
Yeah.
Okay. Usually it's okay. So you have to find the perfect angle to put your magnet on the battery to make sure it's spinning. And also, if you notice, once it goes to the edges, it stops spinning. Well, not spinning, but once it goes to the edges and you didn't strip the wire there, it's going to stop. So that's why you have to strip the wire completely. So there you go. You can all try this one from home because it's more easier to do and it won't heat up as much. If you do make these at home, could you please share them with me? They're easy to make.
Okay.
Okay, so all you need for this one are 2 paper clips, a battery, a motor without a hole, a magnet without a hole in it, and just small thin copper wire. And remember how you can strip the wire? One side has to be completely stripped and the other side has to be half stripped. So like you might say, if it's not working, it's either your wire, you like stripped the wire wrong, or your magnet is not in the correct position where it connects to the loop. So it has to be like at the perfect angle. Like this isn't straight. This is like a little 15 degrees off from straight. So it has to have like a good angle for where where the loop can feel the magnetic field. So this will spin until the battery dies. It's very cool to make. You could use it to like do simple things like turn a fan, like a paper fan, or a small Lego wheel or something like that. So do you think this is cool?
Yes, very cool.
Thank you. So the electromotor all it does is it's a motor that turns electrical energy to mechanical energy. So the electrical energy is coming from the battery, and all this is doing is making a mechanical energy, which is just physical movement. So the physical movement is the spinning of this loop, and that's all it does. The coil will spin, and this is called this part of the motor is called the rotor. It's because it's spinning. And the magnet should touch the coil for half of the spin. So you just have to like make sure it's spinning, and you can, if it's not working, you can just give the loop a push and it will spin by itself. It will spin until the battery does not have any more voltage. It should continue spinning. Yeah. That's all I have for today. For next class. For next class, I'll teach you like on paper how you can measure voltage, current, resistance, and all the like other units with a multimeter and get like in a battery. Also, for both the electromotor and the electromagnet, make sure you have a Duracell C battery, because like I told you yesterday, the difference between this battery and this battery is the current. They're both 1.5 volts, but this one has more current going through it. That's why it's more easier for the electromagnet to get attracted to other things, and it's easier for this coil to spin. So make sure you have the Duracell C batteries if you want to make the electromagnet and the electromotor. And then we'll learn about just batteries and battery types on Monday. Okay, yeah, that's all. If you have any questions, you can ask me. Does anyone have any questions?
No.
Okay. That's all I have. Also, you could also try using these type of wire. This is 18 Og for the electromotor. It's very hard to use thick wire because you can't make it into something like this. The current that's going through this is not enough to make this whole, this is way heavier than this. This copper wire is more heavier than this copper coil. So make sure you're using thin wire on the electromotor and very thick wire on the electromagnet. That's all I have. Yeah. If you have any questions, you can ask.
Bye.
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 Thank you.